For some people, a salt is something you sprinkle on French fries, and some people just have salty personalities. But for a chemist, a salt means a compound that is bonded ionically. Two ions bonded together. So what's an ionic bond and how do you name it? Ions form because atoms want to be neutral to overcome instability. Aren't we all trying to overcome that? Quick review of the periodic table. Elements on this side of the periodic table are positive because they have fewer than 4 valence electrons, so they're going to lose those outer electrons and they're going to gain a positive charge. On this side of the periodic table, we have elements that are going to gain electrons to get up to that octet rule, so they're going to get a negative charge. Extra electrons means negative. Quick reminder, in an ion, a cation has a positive charge. It's not pronounced cation, it's cation. I drew a little cat because it has it's positively charged. I'll see myself out now. And an ion is negatively charged, not anion, an ion. I was trying to draw an onion. I'm an artist, you know it. So the onion is negative, so it's crying. So cation positive, an ion negative. An ion, if you don't remember, is an atom or group of atoms that carries a charge. So it has a positive or negative charge. It doesn't have an even number of electrons, so because the electrons are uneven, it either has extra electrons for that either atom or group of atoms, or it doesn't have enough electrons for that atom or group of atoms. There are a couple of rules to remember when you're naming ionic compounds. The cation or positive ion is first. If the anion or the negative ion is monatomic, you change the ending to "ide." Monatomic means that it only has one kind of atom. So all of these here, they only have one kind of atom. Even though this has 2 chlorines, there's only one kind of atom for my anions here. Here I have NaBr, so I write sodium, and then bromine, I change the ending to bromide. NaCl, Na is sodium again, Cl is chlorine. So since Cl is a monatomic ion, there's just chlorine for my anion, I write sodium chloride. Instead of sodium and bromine, it's sodium bromide. Instead of sodium chlorine, it's sodium chloride. So I have calcium, and then again it's chlorine, so I change it to chloride. Ki, K is potassium on the periodic table, and I is iodine. Potassium, instead of writing iodine, I write iodide. Potassium iodide. So we can go the other way here. Potassium bromide. So I would look at my periodic table. Potassium is right here, bromine's right here. Potassium has a charge of +1, and bromine over here, it's a halogen, so has a charge of -1. +1 and -1, that balances out, so my final answer would just be KBr. That's my chemical formula. Okay, sodium fluoride. Sodium, again, is a charge of +1, and fluorine, for fluoride, has a charge of -1. So again, sodium and fluorine, +1 and -1, so I just write that out, NaF. That's my chemical formula. Magnesium oxide. Magnesium is over here on the periodic table. It's in the second column, so it's a charge of +2. And oxide is oxygen, so it is over here on the periodic table. I know it has 6 valence electrons and therefore a charge of -2. 2 positive, 2 negative, that balances out. MgO. Potassium oxide. All right, potassium is over here on the periodic table. In the first column, it's an alkali metal, has a charge of +1. Oxygen again is right here, it's a charge of -2. A +1 and a -2. So that means I need 2 potassiums to balance out. So 2 potassiums balance out with 1 oxygen. So I'd write, since there are 2 of them, K2O. That's my potassium oxide chemical formula. Now we can get much fancier with this. If you remember, transition metals can have several oxidation numbers. So how do we write down the charge and how do we figure it out? Well, we look at the other parts of the chemical formula. We have iron, which is Fe. I'm going to write this off to the side. I don't know the charge. And I have oxygen, which I know has a -2 charge because of where it is on the periodic table. Now I have 2 irons. So for me to need 2 irons to balance out, because the whole thing needs to be neutral, if I have a -2 here and I have 2 positive things here, that means each of these needs to be a 1. So if I have +1 and a +1, that would balance out, and that would make the chemical equation I see. So the iron must have a +1 charge. The way I would write that is I would write iron. I need to specify which iron I'm using. So I'm going to put Roman numerals in parentheses, and that will tell me the charge of my iron. So iron 1 in Roman parentheses, oxide, because again it's oxygen, so we change the ending to "ide." Next we have copper, and again copper can have multiple oxidation numbers. So I have copper, I'm not sure the oxidation number, and chlorine. I have 2 chlorines. Chlorine has a charge, since it's a halogen, of -1, and I have 2 of them. So that means there's an overall -2 charge on this side, and to balance that out, this has to have a +2 charge. Well, there's only 1 copper and 2 chlorines, so for that to balance out, this copper must have a +2 charge. 2 positives, 2 negatives, so the whole thing is neutral. So the way I would write that, copper, and since the charge on my copper is 2, I would write 2 in Roman numerals, in parentheses, copper 2, and chlorine changes to chloride. Copper 2 chloride. Tungsten, because tungsten starts with a W. All right, so I have tungsten here, which is a W, and I'm not sure the charge, but I know I have 2 of them. And then I have S, which is sulfur, and I have 3 of them. Now, sulfur is right here on the periodic table. Now remember, that has 6 valence electrons, so it'll have a charge of -2. So each of these has a charge of -2. So that means on this side I have a total of -6, 2, 4, 6. So I have a total of a -6 charge on this side. For that to balance, this side has to have a -6 charge as well. And I have 2 of them, so 6 divided by 2 is 3. So that means that this side, each of these tungstens must have a +3 charge. 3 plus 3, that's 6. 2 plus 2 plus 2 is 6. +6, -6, the whole thing balances out. So what I would write would be tungsten, and there's a charge of +3, 3, and sulfur, changing the ending, sulfide. Now we can go the opposite direction as well. Nickel 4 oxide. Well, nickel, it already tells me 4 has a +4 charge. Oxide is oxygen, so it has a -2 charge. So for that to balance, I would need 2 oxygens, so +4 and -4. 2 plus 2 is 4. So that means my chemical formula would be NiO2, because there are 2 oxygens. Titanium 2 bromide. So titanium, and it already says it has a 2 charge, +2 charge, because it's a cation, it's first, so it's always going to be positive. Bromide. Bromide is bromine, which is a halogen. Bromine has a -1 charge. Again, to balance, you need 2 of them, so 2 negatives, 2 positives. So it would be TiBr2. Tell me there are 2 bromines. All right, let's get fancy. Vanadium 3 selenide. Vanadium is right here on the periodic table, number 23. Vanadium, and it tells me it has a +3 charge. Selenide is selenium, Se, and it has a -2 charge. I like to recognize patterns. So here I had a 3+ charge on my cation and 2- charge on my anion, and ended up with 2 of these and 3 of these. And usually that kind of pattern repeats itself. Another fun thing to look at is 2 charge, 2 of the other kind. 3 charge, 3 of this kind. So if I have a 3+ charge here, 3 and a 2, so the 3+ charge here, that means I'm going to have 3 seleniums. 2- charge here, that means I'm going to have 2 vanadiums. So let's see, 2, 4, 6, 3, 6. So 6 negative charge here, 6 positive charge here. It all balances out. So I would write V2Se3. Now the other thing you sometimes have to look at in chemistry is polyatomic ions. Sometimes you'll have an ion that is more than one atom. So a group of atoms will have a charge. It's important to have on hand a table of common polyatomic ions. Now when you're naming a compound with a polyatomic ion, you do not change the ending. Now remember, when we had monatomic ions, we changed the ending to "ide." Some polyatomic ions already have an "ide" ending, but we don't change whatever their ending is. It stays whatever it is on your polyatomic ion table. So let's look at these. Lithium hydroxide. Lithium is an element, so it's monatomic. Lithium has a charge of +1. Hydroxide is on my polyatomic ion table and has a charge of -1. +1 and -1 balance out. LiOH. And we'd write it like that. Calcium sulfate. Calcium is an element on my periodic table, right there. It has a charge of 2+. Sulfate is SO4, and the charge is 2 negative. So 2 positive, 2 negative, that balances out. So we write CaSO4. Our final answer should never have any charges in it because the whole thing's neutral. Magnesium carbonate. Since it's an alkaline earth metal, we have a +2 charge. Carbonate is a polyatomic ion, CO3 with a -2 charge. Again, positive and negative balance out. So I'd write MgCO3. Now sometimes you might come across something that looks like this. When you have more than one of the polyatomic ion, you have to specify that there are 2 of that whole ion. Because if I just wrote CaOH and then 2, that would tell me there were 2 hydrogens. The parentheses tell me there's 2 of everything in parentheses. So I have calcium, and OH is hydroxide, So I write calcium hydroxide. All right, I have CsCrO4. What the heck is that, right? Cs on your periodic table is cesium. So cesium is in the first column, it's an alkali metal. CrO4 is on your polyatomic ion sheet, and it's chromate. Cesium, chromate. NaOH, Na is sodium, and OH is hydroxide. A lot of people get mixed up when they see things like this because they're like, okay, sodium, oxygen hydride, or something like that. They kind of mix it up, but OH is hydroxide. If we only have one of them, we don't put any parentheses. That throws people off sometimes, but that's how it goes. But you just got to learn the convention. All right, let's try AuSO4. Now, we're getting fun here. Au is gold. Gold. Now, gold is a transition metal, so it can have multiple oxidation states. SO4 is sulfate. Sulfate has a -2 charge. So we have one sulfate, SO4, and one gold. That tells me my gold must have a +2 charge to balance out the sulfate. So it's gold 2 sulfate. And that's how it's done. Once you get the hang of naming ionic compounds, the rules get pretty easy and it comes naturally.